In this video, we will explain how to decide if a matrix is in echelon form. Let me start by some examples. So suppose we have 2, 3, 4, 5, 0, negative 1, 0, 1, negative 2, 1, 4, 7. Then first, we're going to explain the notion of a pivot in a row. Then let's write that down. Pivot in a row. By definition, this is the first non-zero entry in a row. For example, for the first row, the entry A11, let's call this the matrix A, is a pivot entry. For the second row, the entry A22 is a pivot entry. This is the pivot entry. And for the third row, this is the pivot entry. This is the entry A31 is a pivot entry. Then, in general, the pivot in a row, let me just write that down. Pivot in a row is the first non-zero entry. Okay, then we have the notion of the pivot in a row. In general, we say that A is in echelon form if every row in A has its pivot entry to the right of the pivot entry of any row above it. Then, for example, this matrix is not in echelon form because the pivot entry of this row is not to the right of the pivot row of this one. Let's do more examples. If we have 3, 2, 1, 4, 0, 1, 2, 1, 2, 0, let's say 0, 0, 0, 1. Then this one is in echelon form. The reason is because when we check any row, for example, if we check this row, the pivot of this row is to the right of the pivot of these two rows. And if we check this row, the pivot of this row, which is this entry, is to the right of the pivot entry of this row. And for the first row, there is nothing to check because there is nothing above it. Then this is an example of a matrix in echelon form. We have like 2, 3, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Then in this case, this one has a pivot and this row has no pivot. Then in particular, this property holds true because the only row that we should check is this one that has a pivot and there is no row above it. This is something that I should have pointed out, that when a matrix is in echelon form and you have a row of zeros, those rows must be at the end of the matrix. Let's do more examples. We have something like 2, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 3. This matrix is in echelon form. This one is in echelon form because when we look at the pivot entries, we notice that the pivot of this row is to the right of these two pivots, and the pivot of this row is to the right of this pivot, and for the first row there is nothing to check. Then we have the notion of a matrix being in echelon form. Maybe it's a good thing to point out that there is a connection between echelon form and what we define as a a good system. Remember that if you have a system, a linear system, A11 x1 plus A1n xn equal to B1, AM1 x1 plus AMN xn equal to Bn, then we can define the augmented matrix of this system. Augmented matrix of the system, and in this case is the matrix A11, A12, A1n, B1, AM1, AM2, AMN, BM, and then we can see that the definition of echelon form is related with the definition of being a good system. We have that this system is a good system if the augmented matrix is in echelon form. Then that's the connection. But I would like to emphasize that the notion of echelon form for a matrix, when you think about the echelon form of a matrix, that matrix does not need to be linked with a system. Then the notion of echelon form is independent of the fact if that matrix comes from a system or not. Please do this homework. Once we have the notion of echelon form, let me define the notion of reduced echelon form. A is in reduced echelon form if A is in echelon form and 2, every pivot entry is 1. Every pivot entry is 1. And 3, all the entries in a column that has a pivot must be 0 except the one from the pivot entry. Then this is what it means to be in a reduced echelon form. If we have an example like A equal to 0, 1, 4, 0, 2, 1, 0, 0, 0, 0, 1, then we notice that the pivot entries are this one, and this one. But here, in this case, we have that this matrix is in echelon form, but it is not in reduced echelon form. Reduced echelon form. And the reason is because this pivot entry must be 1, and in this case it is 2. Every pivot entry is 1. Okay, let's do more examples. If we have B equal 1, 0, 0, 2, 1, 0, 0, 1, 0, 1, and 0, 0, 0, 1, 0. In this case, this matrix is in echelon form because when we look at the pivot entries, these are the pivot entries. Remember, the pivot entry is the first non-zero entry in a row. And this property, every pivot entry is 1, then this property is true. It is in echelon form, but this property is not true. When we look at this column, all the entries are 0 except this one, then this column checks the property. when we look at this column that has a pivot, all the entries are 0 except the one from the pivot. And when we look at this column that has a pivot, not all the entries are 0. Then because of these two, then this matrix B is not in echelon form. Please do this homework.